Introduction. So hello everybody, I welcome you all to this webinar where I will be building an end-to-end application along with you. So we will be building a chatbot with Llama Index. So let's jump, if that sounds interesting, let's jump to the agenda of today's webinar. So first of all, we will discuss about the evolution of foundation models, how it all started with transformers and then it drilled down to ChatGPT. And then we will discuss why orchestration frameworks are required. And some of those are LangChain, Llama Index, and others as well. So, and then I'll be building an end-to-end application with you. And after that, we will deploy our application on the Streamlit Cloud. So let's jump to the evolution of foundation models. So I know most of you have tried ChatGPT. So it took them almost 2 days to reach 1 million users. So foundation models are basically large language models that are trained on massive amount of public data. So you can take this example that if I put the large corpus of Wikipedia data and train my language model on it, so it would be it will have a general knowledge of all the history of the world. And when I will I will fine tune the model with specific data set, like work as a co-pilot for me. I will ask some questions to him. So the chat GPT is usually called before as an instruct GPT, where we are asking some questions from the large language model and it is giving us the response. So the whole science behind this particular language model is it was trained on a large corpus of data which has a lot of general knowledge, and then we fine tune it with particular question and answers that you have to, if you have been asked this question, you are supposed to respond in this manner. So we fine tune the model, and then at the end we test our final model with the test data set. So that's how we build a large language model from scratch. So what you see nowadays, such as Bard, ChatGPT, or Claude, so they are foundation models which are built on billions of parameters and a huge amount of public data. So what OpenAI did, they scraped the websites and put all the data into the context of their language model, and they build ChatGPT on top of it. So this was a brief introduction about how foundation models works. So there are particular challenges that you may have also faced during your interaction with ChatGPT. Sometimes this is just a very common problem that sometimes when you put a prompt that is too long, your ChatGPT will gives an error that the prompt was too long and it cannot cover into the context window of the model. So I really believe this is something a very usual use case. And then there is another challenge. If you have an organization and your data is split into various disparate data sources, such as you have videos on YouTube, you have your database on the on-prem side, and you have some documents in the books as well. So how you are going to organize your knowledge base? How you are going to ask questions from the YouTube videos you have put it on? So there comes this challenge that most of the financial companies have disparate data sources, and they want a single organized knowledge base where their data has been integrated, and they can build a language model on top of it and can ask questions from this. So there comes a solution to this. So the solution to all of these problems with language models is an orchestration framework. So consider orchestration framework as an agent. What it do, it deviates it gives the context to your language model by storing the data in a vector database or getting or doing the semantic search, and it gives the context to the language model along with your query, and then you would be able to get a well-informed answer. So there are multiple orchestration frameworks that are, you can say, uh, there is LangChain, there is Llama Index, there is ZenML. So these orchestration frameworks basically helps you in building applications with large language models. So you can ask questions with your data set. So moving forward towards the solution. So let's suppose if you want to ask some questions from a book which has you can say 380 pages. So you cannot put that 380 pages directly into a large language model and ask a few questions from it. So what orchestration frameworks do, they basically chunk your data set into separate pages, and it store them into a vector database. So whenever you ask a particular question, it will do this semantic search and get the context from the database, and then feed that context plus the query in the model. So that's how things get evolved from if you want to ask questions from a large corpus of data. So you have to chunk or slice it down into smaller pages. So you would be able to get a quick response from it. Moving forward towards the architecture of an LLM application is that we have the same problem that our data is too big. So what we are going to do, our first step is to chunk the documents into uh, bits and pieces. So we are going to chunk the 380 pages into bits and pieces. Then we are going to index that particular data into our vector databases. So there are various vector databases. We have Pinecone, we have ChromaDB, so we have Waviate, and there is PG Vector. So what it does, it it index your data using we have multiple indexing techniques such as LSH, we have product quantization, we have hierarchical navigable small world that we call as HNSW. So there are various techniques to index the data into a vector database. So we are not going to delve into the intricacies of that. So one thing that you need to remember is when you have a large amount of data, you're supposed to chunk the data with the help of an orchestration framework, and it will store those embeddings into a vector database. So what will happen once you will ask the question, once the user will ask the question will will send a query to a vector database where it will do this semantic search with the data, and it will get the relevant documents for the query. So what it does in the background is it creates embeddings and gets the relevant questions. So if we go back to the next slide, so I'll come to this architecture after this. So, so what I was telling you that once we have created these embeddings, our language model can get the context from the vector databases, and then we will put the query and the relevant document to the language model so it can provide a successful result. Okay. So moving towards the next slide, we have vector embeddings. As I was telling you guys before that we create embeddings from the data we have chunked. So let's suppose we have three examples. Today is a sunny day. That is a happy dog. That is a very happy person. So we have these three different sentences. So we can have any embedding model from Hugging Face or from OpenAI, where we can ask those APIs to create embeddings for us, and embeddings are just numeric vectors in an array. So as what we do, we convert those text sentences into numeric objects, which we also called as array. So these are just vectors of numeric numbers. Then moving forward to what happens in the vector similarity search. So as you remember, in this architecture, we chunk our data, we store it in the vector database. Now there comes this particular task. When the query comes in, it do the vector similarity search. So moving towards the next slide is how vector similarity search works. So let's suppose you stored these three sentences in your database. That is a very happy person. That is a happy dog. Today is a sunny day. So what it does, so this will be a query vector. That is if someone asks, that is a happy person. So this would be a query sentence. What it does, it will calculate the cosine similarity between two vectors, and cosine similarity is just the angle between two vectors. So uh, the least the angle, the more the similarity would be. So as you can see, that is a happy person is 94% similar with that is a very happy person. So what the vector database would do, it will fetch the top three sentences that are relevant to your query, and it will fetch those as a context in the language model. So that's how vector similarity search works. So moving towards this architecture, if I present it again, so now everything's will get clear to you that first what we did, we chunked our data into bits and pieces. We store them into a vector database. Once the user asks and prompt a question, the question will go into the vector database where we will have vector similarity search. And after getting the relevant documents from the query, we will fed the question and the relevant docs in the language model, and the model then combines the input prompt and the documents and returned with the summary. So this was the theory about how orchestration frameworks works. So let's go straight to the demo. So we have some prerequisites for these. So I'll be sharing a GitHub repo link where I'll be providing the complete code of this webinar. So you just have to clone the GitHub repo and follow the steps mentioned in the README file. And then you must have a subscription on Streamlit Cloud that is for free, so you can deploy your app on the cloud. Okay, so if my screen is visible, so let me start the coding part. So I'll create a file. I'll open it with the code. Okay, so let me create a file app.py. So first of all, these are some requirements you need to install before starting with it. Requirements.txt. So you have to pip install Streamlit. You have to pip install OpenAI. You have to pip install. No. These are the three requirements before starting. So I have already installed these three requirements. So I'm just importing Streamlit as st. If none of you guys are aware of Streamlit, so Streamlit is just a Python package that is used to build web applications. So I'm going to call Streamlit as st. Then I'll make main function. So, and I'll create an initializer over here. So whenever I run this particular file, it will run the main function. So I have initialized it. So let's start building our application. So first of all, I'm creating a header with the Streamlit. So we can call it our application name as chat data. Okay, so let me run the terminal. So, Streamlit run. So it has locally deployed it on localhost 8502. So application is up and running, and I guess yes. Okay, so after this, we can create a sidebar with the Streamlit as well. So we're gonna write with st.sidebar, and we have st.title. We can call it as data. So I guess we control save it, and then the application will start appearing over here. Okay, so we got our header over here, and this will be our sidebar. So I'm gonna place the documentations for Llama Index and Streamlit in the sidebar. So let me place it over there, st.markdown. So these are some links for these websites. Let me just copy and paste them over here. So I control save it, rerun the application, it will appear over here. So Streamlit has a pretty cool documentation over here. So I have placed a link, you can go through it. Then we have Llama Index. So they have a pretty cool documentation as well. So you can run through their documentation and start building your applications on it. Okay, so let's close our sidebar and get back to our main function. So first of all, if we go back to the architecture, we need our data. Then we are supposed to chunk it, and we have to set up a vector database. So whenever we will ask a query, it will retrieve the semantic document and we'll get the response. So first, let me create a data source over here. We're going to create a file data, and I'm gonna copy a PDF into this file, particular folder. So we have our data source ready. So we just need to read this particular file. So what we are going to use, we are going to use a simple directory reader from Llama Index. So I'm going to import it from Llama Index. From Llama Index, import simple directory reader. So what this particular package do, it reads the it reads the data from your directory. So I'm going to initialize that reader is equals to simple directory reader, and I'm going to provide an input directory over here. So let me remove the backticks. So input directory would be equal to colon slash data, and then I'm going to tell them that recursive is equals to true. So we have set it up our reader as well. So we are going to say that docs that we are reading is equals to reader dot. We're going to call this function load data. So what these two lines of code will do, it will read the data from your directory that I have initialized over here. So whatever I'm storing in this particular folder, it will read it and create embeddings out of it. So now going back to the architecture, we have set it up our database. So we will be chunking our data and storing it into the database. So let's do the second part of it. So we have, for this very purpose, we have service context. We have service context, and we're going to import it again from Llama Index. Import service context. So service context is just, it creates a context throughout your LLM application. So we are going to initialize it as service context is equals to service context dot from default. And now we are going to tell, so the LLM that we are going to use is from OpenAI. Just import. So I'm just importing an LLM from Llama Index dot LLMs import OpenAI, and I will further import the vector store as well. Llama Index import vector store index. All right, so we have our LLM and our vector store index imported. So let's start integrating that. So we are going to say that from defaults, LLM is equals to open AI, and we are going to initialize the model. So model, we will be using GPT 3.5. So you can also use GPT 3.5 Turbo as well. So let me bring that 3.5 Turbo. Then we will be setting up a temperature as 0.5. So temperature is just basically a number that if we set it up to 0, it will get the same response. And if we set the temperature to 1, it will always try to get a different response for every particular problem. Okay, so now I'll be writing a system prompt to it. System prompt. Right. So system prompt is just a prompt which we gives to the language model at an instance that you are an expert on machine learning and you're supposed to do this and that, as you have probably used it in your daily workloads, that you provide a prompt to the language model and it works pretty well on it. So let me initialize it as you are a I'm saying it as you are a machine learning expert because I have indexed a research paper on machine learning. So let me complete it. You are a machine learning you're a machine learning expert. Machine learning is to answer technical questions. To answer technical questions. So this is a prompt that I'm providing it. So I guess we are good to go with this. So we have set it up our context as well. We have we have loaded the documents as well. So now we have to index them into the vector store. So I'm creating an index is equals to vector store index dot from documents. And I'm going to say that docs, comma. So it takes two parameters, that is service context and docs. So we are good to go. So after this part, we have indexed our documents as well. We have set it up our vector index as well. So the last part is we will be creating a chain where we will be asking a prompt from the user and it will be replying. So let's create that particular thing. So we're going to say if query is valid, then I can create a chat engine over here. So what this particular variable is just it takes our query and it takes the query and the relevant documents and it gives those two things to the language model. So it provides a valuable response to us. So I'm going to ask if query is available, is not none, then chat engine would be index dot as chat engine, and provide a mode as well over here, that is condense quotient, and then we are going to set so this would be a variable we have stored it as this, and then we are going to say verbose is equals to true. So I guess this is it. So we will be getting our query and we are asking if that is available, so we can get our response from the language model we are using. So now all we have to do is we are going to ask the response is equals to chat dot chat, and we are going to query. We are going to place a query over here. So what this two lines of code is do, it gets your query and it gets the syntax from the index and it will provide a valuable answer to you. So now I'll write st.write and we're going to print the response as it has another value in it. So this is it. Okay, so I guess we are good to go with this. Okay, so let's rerun our application, and I'm supposed to provide an so okay. So basically we have so I'll be providing an API key in the .env file. So for this particular application, you must have a .env file and an API key. So let me just load that particular key over here. So all you have to do is you have to from .env import load.env, and you're going to call that particular function over here. So it will get those API key into your environment variable, and I'm going to import OS as well. So Open API gives us an API key which we can use to connect with their language models. So I'm going to initialize that as Open AI dot API key is equal to os dot get env, and I'm going to set it as Open AI API. So we are good to go. So let me just save all those files and bring this, and we are going to rerun this application. So we have indexed our data into the vector store. So we'll be asking a query from this particular research paper, and we'll be getting the response back from the ChatGPT. So I guess, okay, so the error is over here is name query is not defined. So, okay, so we have to define it. I forgot this particular line. So let's define query is equals to, we're gonna say st dot text input. So I'm just initializing a text input where I'll ask the user, ask questions related to your data. And I'm going to control save it and go back to my application, rerun the application. Let's see what I have. So let's go into this research paper. Let's ask some typical questions like what are the names of the authors of this paper? What are the authors of the research paper? So what we did, we chunked our documents, stored it into a vector database. Now we are querying the language model. What it will do, it will go into the vector database, get the relevant documents, and the query and the relevant documents will go to the language model, and it will get the response for us. Okay. So as you see that the authors of this research paper mentioned in the conversation that they have provided. So we got the answer. Let's ask some typical question from this. So something from over here. So we can ask this model about what is the cost to train the GPU produce. All right. So let's ask this question. What is the cost to train? Let's see what the response we will get from it. Okay, so we got the response that the training the GPU cost is approximately $800, including several failed trains. So this is how it works. So the orchestration frameworks such as LangChain or Llama Index, they help us in building LLM applications on top of our own data. So as you see that the data that is stored in my local directory is getting indexed, then the OpenAI creates embeddings for it, and then we can ask a couple of questions from this. So this is the modern architecture of these LLM applications, that any data that is stored either on an on-premise database or either in the cloud, you can create embeddings and then index into a vector database where we can use vector similarity search to get the relevant documents for the query, and then we can combine both of these things and get a useful response from a language model. So there are various amount of open source language models as well. We have Llama 2 from Facebook that we are also planning to create another webinar on it. So you don't have to, you won't be requiring a OpenAI API key for these applications. You just have to deploy your language model on either Hugging Face platform or locally on your own setup. So you can use those models as well to boost up your productivity of your organization as well. So this was a small demo of how you can build an LLM application with Llama Index. So I have covered briefly every topic of this. So I'll be providing the complete code of this architecture as well. So it just, you can see 40 lines of code and it is working pretty fine. So if you are a student and you have an exam tomorrow, you can ask some relevant questions by just indexing your book in this application. So it really helps a lot of organizations, such as we have financial organizations who wants to who has disparate data sources. They have videos on YouTube, they have data on-premise databases. So all of these data can be combined through an orchestration framework that is built to help uh, build LLM applications scalable and autonomous. So I guess, Nathan, we can get started with the questions.
Perfect. Sounds good. So okay, so I'm hoping you understand these without context, because I really don't. I think at the start you said something about a large model. So somebody's asking, how large is the large model?
So basically, large language models are like built on millions of parameters. So there is one model from Anthropic that is called Claude 2. It has 100K token limit. So if you are planning to index 2 or 3 books in a prompt, it can be done through Claude 2. Okay, so let me read out some of the questions. Okay, so there is a very nice question from Harry. So is any of your data, the pages you chunked, sent to OpenAI? Yes, it was sent to OpenAI. For reasons of privacy, many companies wouldn't allow that. Yes, and the solution for this is deploying your own language model either on a cloud or on your own computer as well. So you can deploy a Llama 2 model and start using it as an LLM, and the rest of the architecture would remain same. You just won't be querying through an OpenAI API. You will be asking your own language model on it. So okay, so let me read the rest of the questions.
How about I think it's Valentine. Is the order of input information relevant during the RAG retriever augmented generation?
So for RAG, the order of indexing does not matter, because at the time of query, the what the vector database will do, it will do the vector similarity search with the query you are providing. So when the query comes into the vector database, it calculates the similarity between the vectors that are already stored in terms of embeddings. So it will get the top 3 vectors from it and will provide you a useful answer.
Okay. And then Harry has a response to your answer to his question. So he's asking, oh, I lost it. If you use OpenAI on Azure, does that keep your data private, or do you really need to create your own thing?
So as So we have used OpenAI on Azure as well. So they are called Azure. There is Azure OpenAI. So where we have particular APIs, so you can connect with those APIs as well. But it will still track your data, because at the end of the day you will be contacting with the API of OpenAI. So I would prefer, if you have data privacy issues, you can deploy your own language model either on Hugging Face platform or on your own computer, and there will be a compute cost for you, because the language model requires a lot of uh, RAM to run. So you have to bear the compute cost in order to in order for the data privacy you're looking for.
Okay. And Harry, I know you have another question, but I'm gonna have some other people get their questions answered, and then come back to you. So Andrew's asking, what would be a good format to store the data of a traditional RDBMS table that an LLM would most easily understand and return human readable answers? For example, just a JSON array of all the rows with JSON objects or key value maps would suffice. There's a second part to that, but I'll leave you at that.
So the part I got from your question is for indexing the data that is already on an on-premise database. So we have various indexing techniques to store the data in vector store, such as we have hierarchical navigable small world, where it creates layers of your data. So it drills down to the particular layer according to the semantics similarity you are looking for. Then we have locality sensitive hashing as well. That is also very useful for structured data. So if you have a structured data in your database, you can index it using any of the techniques, and you will get a useful response from the language model.
Okay, sounds good. And then I think this will be a quick answer, but can the algorithm relate the current document to previous data that ChatGPT was trained with?
Can you please repeat that thing?
Can the algorithm relate the current document to previous data that ChatGPT was trained with?
So I would say it cannot relate it, because the previous data it was trained on, it is in terms of embeddings, and it is in terms of numbers. So whenever you put your prompt into it, it will do the semantic similarity search with the particular embeddings it has in its vector store. So the model has been trained on huge amount of data. So it has the understanding of almost every general knowledge. So whenever you will ask something, it will get back to its knowledge base and get the relevant results from it.
Perfect. And I don't know if you're actually the best person to ask this question, or if somebody that's more embedded in IT would be better. But if you were to run a large language model on your own computer, what would the specs have to be?
So I really believe that I might not be the right person to answer it, because as you see, language models requires a lot of memory compute. So OpenAI is investing millions of dollars on the compute cost. So you can search about it, like Hugging Face is providing you a platform where you can deploy your model on it. So you don't have to bear the compute cost. They have this particular, you can say, a resource where you can deploy your language models on it.
And then in the example that you did today, sorry, my nephew is ringing the doorbell and my dog is barking at it. So, Sadie, come on. Sorry, Zaid, I'll be right back.
So yeah, I can go ahead with the next questions. So we have this particular question from Harry. Say, what do you recommend for creating your own LLM model instead of OpenAI? So I would recommend you go ahead with Llama 2. and deploy it on Hugging Face platform, and you can start using it for your further responses. Okay, so where was the index vector stored? So, okay, so we have a question from Rohit. So he's asking, in your example, where was the index vector stored in on your local machine? Yes, exactly. So I did a previous webinar in which I use Redis as a vector database. And in this particular webinar, I utilized my own local machine to work as a vector store for me. So I placed my data on the vector on my local machine. I asked the OpenAI to create embeddings on top of it so it can do the vector similarity search. Right. So, so there's another question. Would LangChain help automate any of your example, or it is meant for other things? So LangChain is also similar to Llama Index, which is also an orchestration tool. So you can also build a chatbot with LangChain and create agents. So if, let's suppose, you have a data and you want to perform any actionable instance through it, so you can create an LangChain agent on top of it as well.
And then a question from Sean. In your case, you inputted a PDF as your data repo. Is there an easy way to point these orchestration tools at multiple existing internal repos and have the tools index a company's knowledge stores?
Yes, so these are these orchestration frameworks provide various data connectors. You have a YouTube loader, you have an on-premise data loader, you have a CRM loader. So if you have disparate sources of your data, you can converge them to a single knowledge base using these orchestration tools. So that was a really good question. And I really believe that all those emerging architectures are converging the disparate sources of data into a unified knowledge base.
Okay, I think one more, or let's make sure, because I know Harry had a question up above and I've lost it.
Yes,
but
I did respond to that.
Okay, perfect. So I know Andrew's got one more question, so maybe we can do Andrew's question and then call it, because I think one way or the other you've actually answered almost everything. So Andrew wants to know, have you ever had a use case or an application, not a human user, use a RAG plus LLM to retrieve search results, similar to how you'd build a custom search engine with Elasticsearch, but you have saved a lot of time with an LLM?
So I lost you in between. Like, what was the
Yeah, I open up
question?
the Q&A tab and read it.
Yeah.
It's all the way at the bottom. It'll be easy to find.
Okay. So it's a really big question. So what would be a good format to store the data of a tradition? So okay, so have you ever had a use case where an application, not a human user, used a RAG? Yes, there are particular use case where you can create agents. There is AutoGPT, there is GPT bot, which can use a RAG and LLM application to retrieve results. So if you search on Google about these bots, so there are various autonomous agents that are created using LangChain. So they can do these things, and they usually save a lot of time.
Okay, and I lied. One more question, because Harry was able to find the one that I was thinking of. How is a sentence turned into a single vector? It seems that there would be a point for each word embedding.
So yes, let me converge it to a certain point. If you have a bit understanding of how attention mechanism work, so it works in a similar way that if you have a particular sentence, your cat is a lovely cat. So it will create embedding of each of those words and then store them into a array of vector. So there will be an embedding for your, there will be an embedding for cat is a lovely cat. So every word, every token of word will have a embedding on it in, you can say, multiple various dimensions. We have 568 dimensions, we have 4096 dimensions in Cohere. So then we converge all those embeddings into a single array of vector for a particular sentence. That was in our case.
All right, perfect. Thanks, Zed.